Now that we've considered HSRP, which is a Cisco proprietary first hop redundancy protocol, let's consider an industry standard, VRRP. VRRP stands for Virtual Router Redundancy Protocol, and it's very similar to HSRP. There are a few subtle differences. Let's take a look at some of those. First of all, notice that we still can have a couple of routers that are capable of forwarding traffic off of our local subnet. In fact, we could have more than 2 routers or multi-layer switches. But here, instead of calling R1 the active router, it's actively forwarding packets to the internet right now. Instead of calling it the active router, we call it the master router. And instead of calling R2 the standby router, we call it the backup router. And something else that's significant, notice that the virtual router has an IP address of 10.1.1.2. The default gateway of the PC is pointing to 10.1.1.2. That's the address of a physical interface on R1. We could not do that with HSRP. But here, the virtual IP address can be an IP address that's assigned to a physical interface. We don't need to do it this way, and typically we don't do it this way, but if you really need to conserve IP addresses, it is an option, so that's the reason I illustrated it that way here. And if the master router goes down, then the backup router is going to transition into the role as the master, and traffic is going to be forwarded via R2 in this case, out to the internet. And where HSRP had hello messages that would be sent out at an interval of 3 seconds by default, here the advertisement interval is going to be 1 second instead of 3 seconds as a default, and we can modify that if we want to. And also, just as HSRP was able to do object tracking, for example, it was able to keep track of an interface that goes out to the internet, and if that interface goes down, R1 could react to that and decrement its priority. VRRP can do the same thing. So to better understand the differences between HSRP and VRRP, I thought we would do a side-by-side comparison. It's not really like comparing apples to oranges because there are so many similarities, but there are some specific differences that I want you to know about. We've already mentioned that HSRP, it's Cisco proprietary, while VRRP, it's an industry standard. If you want to read the details, the technical ins and outs of these protocols, there's an RFC for each one of them that we have listed on the screen. With HSRP, the router that's actively forwarding packets out to a remote network, we call it the active router. With VRRP, it's called the master router. The router that's in standby mode, waiting to take over the role as the active router with HSRP, we call it the standby router in HSRP, but it's called the backup router in VRRP. And the virtual MAC address that gets associated with the virtual IP address, that's going to be different between HSRP and VRRP. And you might remember from one of our HSRP videos that HSRP versions 1 and 2 have different MAC address formats, where the X's on screen get replaced with the hexadecimal representation of the HSRP group. Well, similarly, VRRP has a different MAC address format, where the X's get replaced with the VRRP group. Another difference is HSRP does not have the preempt option enabled by default. It is enabled by default with VRRP. Do you remember what the preempt option did for us? The preempt option says that if a router had been the active router, or in the case of VRRP, it had been the master router, and it went down, and it came back up, it would regain its role as the active or as the master router. The timers work a little bit differently with HSRP and VRRP. The default hello interval with HSRP is 3 seconds. The default master advertisement interval with VRRP is 1 second. And the default hold time for HSRP, the time after which the standby router will consider the active router to be down, it defaults to 10 seconds. However, there's a different timer with VRRP. It's called the master down interval. And it's not something that we explicitly set with a command. It's going to be 3 times the master advertisement interval plus something that's called the skew time. The skew time is 256 minus the VRRP priority, and we take that number and divide by 256. So if you think about it, the higher the VRRP priority, the lower the master down interval. We also see that HSRP communicates via multicast using a multicast IP address of 224.0.0.2 if it's HSRP version 1. By the way, that's the multicast IP address for all routers. But with version 2, it uses 224.0.0.102, but VRRP uses a multicast address of 224.0.0.18. And one of the differences that we've already mentioned is that with HSRP, we cannot use an interface's IP address as the virtual IP address. However, we can with VRRP. Now that we've talked about the theory of VRRP, let's go ahead and see how to configure it in our next video. The configuration of VRRP is really similar to that of HSRP. We're going to go into router R1, and just like we did in our HSRP demonstration, we're going to go into interface fast Ethernet 0/0, and here's how we assign the virtual IP address. Now, even though we could use the same IP address that's physically assigned to this router, we're not going to. Typically, we don't. But it is an option with VRRP if you need to conserve IP addresses. You can use the IP address assigned to a physical interface, but generally I will not do that. Let's set up the virtual IP address by saying VRRP, and then we give a group number, just like we did with HSRP. I'll say group number 10, and we specify the virtual IP address. It's going to be 10.1.1.1. That's the default gateway to which our PC is pointing, and I want R1 to be the master router. And to make it the master router, I can set its priority to something higher than 100, which is the default. Right now, it's the only router participating in this VRRP group, so you see that currently it's the master, but when R2 is configured, I want R1 to be the master, so I will say VRRP group number 10, priority 110. Now let's go into router R2 and set things up there. On router R2, let's go into interface fast Ethernet 0/0, and again we will say VRRP group number 10. Virtual IP address is going to be 10.1.1.1, and because we have a default priority here on R2 of 100, we should become the backup, and we see on screen confirmation that yes, we did become the backup. We can give a command of show VRRP brief, similar to show standby brief that we did with HSRP. To get a great overview of our configuration, we see that fast Ethernet 0/0, that's the interface participating in VRRP. The group number is 10. Our default priority is 100. This is our master down interval, which is 3.609 seconds right now. Under own, we don't see anything because we're only going to get something there if the virtual IP address is the same as the IP address of a physical interface. In other words, a router could own that address. It's assigned to that router's interface. Here, that's not the case. We're just using a virtual IP address. And the preempt option is enabled. It's enabled by default. I didn't have to set that up. Our current state is backup. Who is the master? It's R1. 10.1.1.2, and the group address, in other words, the virtual IP address that we're servicing is 10.1.1.1. Let's go check things out from the perspective of R1. Let's do a show VRRP brief command, and we see that our priority is 110. We're the master, and notice that there's no identification for the backup router because we could have more than one backup router. And you might also notice that the master down interval is a little bit different here than it was on R2. On R2, if we go back, it was a bit over 3.6 seconds. Here it's a little bit over 3.5 seconds. And the reason is this router has a higher VRRP priority. These two routers have different skew times, and we'll talk about that in just a few moments. But for now, let's watch VRRP in operation. Let's go to PC1 and start a series of pings to an IP address of 1.1.1.1, and we'll give a bunch of pings. So we'll have a steady stream. There we go. Now let's go over to R1, and in interface fast Ethernet 0/0, let's shut it down. And did we lose any packets? We lost a couple, but the cutover time was much faster with VRRP than it was with HSRP by default, even though we could adjust the HSRP timers to something lower than the defaults. But right now, if we go over to R2, we should be the master. And indeed, we already see that we are. We transitioned from the backup to the master. We can confirm that with the command show VRRP brief. Now let's go to R1 and bring Fast Ethernet 0/0 back up. I'll do a no shutdown. And remember, I did not configure the preempt option on either of these routers. However, we just saw it on screen, router R1 is now the master. And that's because with VRRP, unlike HSRP, the preempt option is enabled by default. And just like we could do a show standby brief command to get an overview of our HSRP configuration, but we could do a show standby command to get more detailed information, same thing here, we can do a show VRRP without the brief option to get more detail. Let's do that. Let's do a show VRRP for router R1, and let's notice a few things. First of all, the virtual MAC address. The format is a bit different than it was with HSRP. We don't have the Cisco vendor code as we did with HSRP. We're going to begin with 4 zeros, 5E0001, and then the last 2 digits. That's going to be the hexadecimal representation of our VRRP group. In our case, it's 10, and 10 in hex is an A, so we have a 0A. Advertisement interval, similar to the hello interval with HSRP, defaults to 1 second. With HSRP, the hello interval was 3 seconds, you recall. Preemption is enabled, even though I didn't set it up. We see our priority value is set to 110. We are the master router at 10.1.1.2, and the master advertisement interval is 1 second, and this needs to match up on router R2. However, routers R1 and R2, they've got a different master down interval. The way this is calculated is we take 3 times the master advertisement interval, and to that we add what is called the skew time. Let's bring up a calculator and go through this calculation for the master down interval. The master down interval is going to be the skew time plus 3 times the master advertisement interval. The skew time is 256 minus the VRRP priority, which is 110 in our case. And we take that number and we divide by 256. That's our skew time. So our skew time is 0.570, and to that we add 3 times the master advertisement interval. In our case, it's 3 times 1, or in other words, 3. So we're going to say plus 3 equals 3.570. 3.570, that matches up. So we've got a master down interval that's a little bit less than what we would have on R2. On R2, let's do a show VRRP. And here, the master down interval is a little bit more because our priority is a little bit less. That's an overview of how we configure and verify VRRP.